We visited the Instituto Maior de Tecnologia in São Caetano do Sul, near São Paulo, to produce biodiesel today. With used cooking oil. And then, I'm still gonna put it in my car's tank and go for a ride. Let's see. You must have heard of biodiesel. It's a diesel oil, but it's made with oil from some plant like palm, castor, sunflower, or with the fat of some animal. But these oils have to go through an industrial process before they can go into the tank of a truck or a pickup. That's what we'll see today with the superb chemical engineering team at Meiwa. Meiwa turned 60 in 2021. It has engineering courses in 9 areas, administration and design. Registrations for the entrance exam are open, and everything will be online this year. You can get in by an online test on November 22nd or December 6th, or an international certification. The registration link is in the video description, where you can find all the information and discover 60 reasons to join the Meiwa team. The oil that we are going to use is this disgusting thing here. It's an oil that came from frying soybean oil, like what was used to make that coxina that I ate at the beginning. The advantage is that we solve 2 problems at once. First, we use an oil that could be thrown away, we reuse this oil, and second, we stop using petroleum. The first step will be to filter, pass through a sieve to remove these food scraps that are swimming in the oil. Let's not put this leftover coxina in my car's tank, okay? Look, here we have 8 liters of oil that has already been filtered, but you can see that even filtered it is much darker than new soybean oil because it's already quite burnt here. The second step is to heat this oil up to 55 degrees. As this takes a while, we have already left oil heating in a stove to make it faster. Let's go. I was going to call this small cup a beaker, but this is the reactor vessel. It's a huge glass jar. Professor, we always talk about reactors. It always gives the impression of a nuclear reactor. But what's the difference to a chemical reactor? What is a chemical reactor?
A chemical reactor is a vessel in which a reaction takes place. A glass cup, a beaker with a stirrer, can be a heating system if there is no reaction, or it can be a reactor if there is a reaction happening, like in the case of biodiesel that we saw here. On a more industrial scale, this tank having a reaction inside with temperature control, agitation, mixing, everything is a chemical reactor. In a way of the utility of its use in the industry. If there was no reaction here, it would simply be a mixing tank with heating or cooling. This is a characteristic reactor for having a mixture. There are other types of reactors, specifically those that do not have any kind of mixture.
It's time to chemically change this oil here. It is a triglyceride. The triglyceride is these oils that we eat, and we need to transform into a set of esters. An ester is a slightly smaller molecule. Each triglyceride yields 3 esters. And we are used to seeing this ester molecule in those artificial food flavors. This crazy thing is the lid of the chemical reactor, which I need to put in here. And in this case, I think I found out that it doesn't get in if the virus is under the structure. This looks like aluminum, but is actually solid stainless steel, weighing about 5 kilos. Go, boy! Afraid of making a mistake. Is it all right? I've already turned on the agitation engine. I'm going to put it. The small hoses are for temperature control, and a thermometer is inserted. I will set it to 400 revolutions per minute and 55 degrees, and a temperature of 55 degrees. Let's turn the little guy on. I need to put 2 ingredients to react with oil. The first ingredient is an alcohol, but I won't be using ethanol from the gas station. I'm going to use methanol. It's a much more toxic alcohol. It's extracted from wood or petroleum. And the advantage for us here is that after the chemical reaction happens, if we use methanol, it's a bit easier to separate the products of the chemical reaction. And I'm also going to use caustic soda. Caustic soda is used to make the mixture a bit more alkaline, more basic. And this way, we favor the reaction. The detail is that I need to mix the methanol with the caustic soda, and they are not very friendly.
Wow, it's hot.
The chemical reaction has begun, evident from the color change, which signifies the reaction is underway. And what's happening here is that the oil and methanol are turning into biodiesel and glycerin. It takes about an hour for this chemical reaction to occur. At this point, it has already happened, and we have biodiesel, glycerin, and a little bit of leftover methanol in the middle. The problem is that all of this is still very mixed, and we have to take it to decant. And here it takes about 24 hours. That's why we've already left another reactor here prepared, and the mixture has been decanting. Now I need to remove this layer of biodiesel that's on top here. We're going to remove the biodiesel from the reactor using a vacuum pump. We have around 1 quart and 1 pint of glycerin remaining. We should dispose of it. Wow, it's really thick. You could sell it as honey, right? Imagine. If you're looking at all this equipment here and starting to like chemistry, but you're not quite understanding what chemical engineering is, I'm going to ask Professor Zé Alberto to explain.
The part about equipment design, industrial unit projects, plant management, financial management, technical management, it's all related to the chemical engineering course, which aims to transform a production to meet a large demand from society. You produce a certain product from raw materials, and you manage to meet this demand in such a way that this quantity makes the price accessible and that the population, the society benefits.
8 liters of biodiesel, and that's what's going in my car tank in a bit, and 1 liter and 400 milliliters of glycerin. When I found out that a bit of glycerin also comes out in the production of biodiesel, I thought, how cool, we can make a lot of glycerin soap. The glycerin soap will be cheaper. Except it doesn't. Since we produce a lot of biodiesel, a lot of glycerin is left over. It's not just a lot, but a lot of glycerin, and there's not much to do with so much glycerin. So here at MAWA, they have a research to transform this glycerin into something that is useful, that we can use in the industry itself.
This is the bioreactor, where the microorganisms transform the glycerin into hydrogen and carbon dioxide.
The process starts here in this glycerin gallon. The glycerin comes out, it's being pulled by a diaphragm pump and goes to a reactor that's inside an incubator. The reaction must occur at 55 degrees C, so it needs to be sealed, but I will open it. This is the reactor. It's a bit different from what we just saw making biodiesel. Inside here are the bacteria. They are eating the glycerin and turning it into hydrogen, carbon dioxide, and some acids. The acids are transported to a separate reactor where microorganisms, including bacteria and archaea, are present. They are going to eat the acid and turn it into hydrogen and methane.
We can see the microorganisms. What should we do? We take the microorganism from inside the reactor and mobilize it on a little plate with gelatin. And we put this little plate in this equipment called a microscope. The microscope sends the image it's seeing here to this computer. And here we can see which microorganisms were in which reactor.
This small device is a gas volume counter. Methane and hydrogen are emitted from here. In short, we converted glycerin, an industrial waste, into useful products.
Hydrogen and methane can be used as fuels. That is, they can be burned for the production of bioenergy. In addition, one of the effluents from this reactor is water, a liquid effluent. This liquid effluent, it can be used as reuse water, but it still needs to go through some treatment.
I believe we're overly focused on theory, as methane and hydrogen are fascinating gases. First, because they float, they are less dense than air. Secondly, they explode. But let's first look at the part that floats. This balloon contains a mixture of equal parts methane and hydrogen gas. If released, It's very clear out here in the field, so you couldn't see the fire coming out. Let's try to do this at the Mawa Court, which is a bit darker. I think it will be cool. Now yes. I think it's time to give that thumbs up, huh? But at first I thought it was kind of bland. So look at it in slow motion now. Our biodiesel could already be put in the car, but there's a problem. It still has a lot of methanol, and that brings two things. Sending this to the gas station is unsafe, as the attendant handling the diesel could get contaminated. And second, that methanol can be used to generate more biodiesel, so what would be done in the industry? This biodiesel in a distillation column, which is this equipment that's behind me. Down here, the mixture of methanol with biodiesel will be heated and starts to release vapor. The vapor will rise through this column inside these little plates. It will pass from plate to plate. There are a bunch of little holes in the plates, and in each one of them, this vapor begins to condense and starts forming a liquid. You can see that the vapor passes through the liquid and forms some bubbles. As the vapor passes through each little plate, crossing this liquid, a part of the vapor condenses, turns back into liquid, and a part of the liquid evaporates. This causes the methanol to become more and more purified. So what is not methanol stays liquid, and what is methanol rises up the distillation column. So that when we get up here, there is practically pure methanol vapor. The problem is that it is still vapor. So up here, we have a condenser, which is a kind of methanol cooler. There is water running. This water is cold. The methanol vapor passes through it, and it starts to condense, turn into liquid again. And you can see it dripping here, and then it will be stored inside this container. And in the industry, this is a very important piece of equipment.
Petrochemical is one of the industries where it is widely used. So in the petrochemical industry, the fractions of oil are separated. Another industry that is widely used, which you may not know, is in the ethanol production industry. This ethanol, the bioethanol that you use in your cars on a daily basis. So ethanol is produced and separated in the distillation column.
Our biodiesel, we are not going to pass through the distillation column because the process is very slow. We're going to put it in the car the way it is because for us, it's not a problem. The critical moment is here. All we've demonstrated is meaningless if this biodiesel can't be used in the car's tank. I left only a quarter of a tank here so that the biodiesel really makes a difference. If it's poorly made, if it doesn't work, it will ruin the fuel that's already in the tank. Oh. Now we're going to see 8 liters of biodiesel made from used cooking oil. Let's see if the car runs. It started. The thing is, the fuel I put in, it's still going to the engine. It hasn't gotten there yet. Let's take a ride and see what happens. Oh, and then it's running. Let's see. The car is idling at 800 revolutions per minute. The cool thing is that here you also get to know the Mawa field, which I think is super cool. Very wooded, spacious. While the biodiesel mixes here with the fuel that was already in the car's tank and goes to the engine, let's understand the difference between regular diesel and biodiesel. The difference is that regular diesel, it comes from petroleum. It is a non-renewable fuel. While biodiesel, it is made from plants or animals. So we can replace it, we can grow the raw material for biodiesel. Due to this, biodiesel is a renewable fuel that emits significantly less carbon dioxide compared to regular diesel. Because the carbon dioxide generated by burning biodiesel, it is absorbed by the plants used to make more biodiesel. Additionally, it has fewer pollutants than regular diesel. It doesn't have sulfur, for example, which causes acid rain. Total success. I'm already on my 3rd lap. Must have run about 2 or 3 kilometers. Sure that the biodiesel has already mixed. The engine is already burning fuel, meaning I'm currently driving a car, in which the fuel I did it myself? This is very crazy. Ran perfectly, huh? If you want to study here at Mauwa, get to know the labs I showed and 100 others, the link to the entrance exam registration is right below the video.